Good evening, all. I'm really happy to be part of this the great ongoing QCrete webinar series. So exactly, we have reached milestone, that is 50. This is 50th program, and first of all, I would like to congratulate QCrete for this wonderful program, very meaningful program, and that too, it is continuously, reached one important milestone. First of all, congratulations to QCrete and the entire team. And at the same time, I would like to welcome Dr. Satish Jain on behalf of Indian Concrete Institute, Mangaluru Center, as well as the QCrete Readymix India Private Limited. And also, there are many, invitees and the people, and they'll be joining in a sometime maybe. So I would like to welcome all the people to this great journey, that is the milestone program, QCrete webinar 50th program. And without wasting much of the time, I would like to hand over the proceedings to Kaushika sir. Sir, time is yours.
Thank you. Thank you, Anil Baliga sir. Myself, Kaushik, speaking on behalf of QCrete Readymix India Private Limited. It is an extremely eventful day for us, and it is a milestone day for us as we are conducting our 50th webinar, which is a very big, I can say, milestone which started during COVID days. And we are really honored today to have with us Dr. Satish Jain. Satish Jain, to be honest, I don't know him for a long time actually. Very recently, I started talking to him, and it is very nice on his part that when I just requested him that a webinar is required on our platform, he agreed, and it is a great gesture from him. And we are really honored to have him on this occasion on a very interesting and a new kind of a sector in civil engineering. Not many have traveled in this particular sector. UHPC is still a kind of a untouched phenomenon for many people actually, and so it is a great event today for QCrete, and I welcome all of you. And I just introduce Satish Jain sir in a very, I can say, is a short biodata. Dr. Satish Jain has about 22 years experience, and he has extensively worked, and he is still working. He is worked between 2000 to 2009 in USA, and currently from 2009 to present year is working in India. He's a licensed structural engineer both in USA and India, which is I can say a great achievement. Apart from UHPC India Private Limited, where he's working as MD, he also leads Satish Jain Consulting Engineers Private Limited, and he has designed many challenging structures, not only in India but also in USA. He has completed PhD in structural engineering in UHPC from Iowa University, USA. He has done masters in structural engineering from Iowa University, USA, and he has done his BTech in civil engineering from NIT RAC, Calicut, India. And his expertise areas are ultra high performance concrete, material manufacturing, structural design and execution, performance based structural design and execution of pre-tension, bonded and unbonded post-tension structures, structural design of concrete and steel structures, including high-rise buildings. Currently, Dr. Jain has taken up many initiatives, one of them being he has involved in promoting the use of UHPC in India through design, application and development, metal manufacturing, training, research, and project management. So, with this short biodata, I welcome you, sir. Thank you very much once again. Thank you.
Yeah. So thank you so much, Mr. Koshika, for those kind words, and it's a great evening today, and thank you so much, Mr. Anil Baliga. Uh, you know, it's great to have everybody over here. This is a very very interesting topic that's going on nowadays in India. UHPC, or ultra high performance concrete as it is called, has started gaining a lot of interest, not only amongst young engineers, but and, the entire spectrum, I would say, as such. And things are very different from 5 years back, right? I mean, 5 years back, probably hardly anybody in the country was talking about UHPC, and today suddenly there is a lot of hype about it. So these are interesting times, and you will see how UHPC or use of UHPC will change the way that you might want to design certain structures. You might want to use it for different applications. And today we are just going to do an overview about it. And then, of course, we'll have a Q&A and be happy to answer all those questions. So very quickly, number one over here. So let me go back to my presentation over here and see if I can move it over. So what did we learn in school? School, I mean, when we went to college and we started studying concrete, one of the first things that we learned was concrete was great in compression, but at the same point of time, it was not good in tension. So that's what concrete is. Now, when it comes to UHPC, that definition changes, right? If you look at UHPC, and if you look at the top diagram on the screen, UHPC is a very, very ductile material. So it is not brittle like normal concrete. If you look at the red line, um, that's for normal concrete, and you see the brittle nature of normal concrete in tension. Basically, in tension, it just comes apart. But when you look at UHPC, you see how ductile it is, and you get a really, really good strain out of it, good strain hardening behavior out of it. Not only that, even in compression, you will see that you get a nice triangular curve, not a parabolic curve, right? You'll get a nice triangular curve almost up to the point of the compression capacity. So UHPC behaves very differently. On the left side, these are some pictures of direct tension tests that I was involved with at Iowa State University. And these direct tension tests gives you a good measure of the tensile strength. So these are not the flexural capacities or flexural strength, but it's a direct tensile strength. And then it also tells you how far you're going to go with your ductility or your strain. So UHPC exhibits, really very high mechanical and durability properties. So if you look at the mechanical properties, right side, you'll see a chart showing a comparison of where a typical normal concrete, let's say M40 is, versus UHPC at about, M150, M160, or all the way. The range of UHPC today, at least, when it comes to structural applications, we are talking about a range of about 140 to 220 MPa. Whereas even for architectural applications, or let me just put it as non-structural applications, maybe, you are at least looking at a M120 in terms of UHPC compressive strength. Second point I would like to raise is if you look at the creep coefficient of UHPC, it is extremely low. See, even for normal curing, normal concrete exhibits a creep coefficient somewhere about 2. right? So you do a 2 plus 1 and you look at your creep calculations or your deflection calculations. But when it comes to UHPC, the creep coefficient, even for normal curing, is right about close to 1. I would directly jump to the elastic modulus at this point of time. Look at the elastic modulus. It's as good as about 50,000 MPa. So if you do some tests, you're going to get probably even a little bit more, 52, 54. Believe it or not, people have made UHPC that have shown elastic modulus as high as about 65, 70,000 MPa. So it's a material that can exhibit really great behavior. Even the abrasion resistance is very high. People are using it in all kind of applications, abrasion, particularly on highway bridges. You're looking at blast resistance, you're looking for military uses. So there's a whole lot of things that UHPC is being used about. And one of the main reasons, let me show you this cube strength and really show you that you do get, there's music, and I'll turn down the music over here, but you do get more than 150 MPa. So here I'm showing a cube. This cube is very small, about a 50 mm by 50 mm cube, size cube. And you might ask, why this smaller cube? But generally for all practical, tests, you could use a 50 mm by 50 mm by 50 mm for your test. And then you can actually, confirm that with a 100 mm cube. So all initial tests can be done with 50 mm, but you might want to, do your final results using 100 mm. So if you look over here, the test, the cube is almost, close to crushing right now, and you will be able to look at the strength on the screen very quickly, and it's about 196 MPa. Voila! So we have some good strengths over here, right? With UHPC, that's what you will typically get. Next, I'm going to show you, this particular screen where durability performance of UHPC is shown, and you will see that this is where the word performance comes from in UHPC, right? The durability characteristics are excellent. So here is a quick comparison of all kind of penetration, water permeability, corrosion rate, etc. And in yellow is where normal concrete is, green where high performance concrete is, and see if you can find those little blues down below, right? So that's where all the blues are, and that's where the UHPC is. So UHPC is extremely watertight. The ingress of chlorides is next to minimal. So imagine, what you can achieve with respect to UHPC. I'll talk about that here in my next slide very quickly. Here you will see, let me come up with the total slide over here, right? What's your target today in engineering, particularly bridge engineering? We are talking about, reaching 100-year service life or even 120-year service life. But let me change that definition a little bit. Instead of just talking about 100-year service life, can we now talk about 100-year maintenance free service life? That's the key word, maintenance free. That's what you can achieve with UHPC. So on the left figure over, you see, something in orange over here, where you build a new structure, over time it deteriorates, you repair it, and then again it deteriorates. The same cycle goes on, and you keep pouring money onto it until 100 years. But with UHPC, see, if you once use UHPC, that's what strategy 1 over here is in black. If you use UHPC, it's good for the entire service life. You don't have to do anything to your structure with UHPC. So the right side, pretty much shows that over the life cycle of your project, there is a huge savings. Now imagine, what India as a country can save, when we use UHPC in the long term. So again, material that exhibits extraordinarily high mechanical and durability properties, and performance is the key. Now at this point of time, there's some confusion in the market, and I want to, come in here and kind of clear that confusion off. So people ask me, what is the difference between UHPC and UHP FRC? You see two definitions down over here, UHP FRC, called as ultra high performance fiber reinforced concrete, or also as ultra high performance fiber reinforced composite. You know, the bottom line is they're all the same. They are exactly the same. There is no difference. All kind of ultra high performance concrete does contain fibers, right? And even in the past days, the word reactive powder concrete has been used a lot. In fact, when people started with reactive powder concrete, there have been people who started making about 300 MPa, 350 MPa concrete at that point of time, right? So, but believe me, there is no difference between all these 3-4 different nomenclatures, and you're free to use whatever suits you, basically. One of the other reasons why you should really look at UHPC as something that is going to be very beneficial, especially in infrastructure markets, is accelerated construction, right? So in 24 hours, it is possible to get a good 60 MPa, 65 MPa strength. And in 3 days, you can be touching right that 100 MPa mark. So believe me, if you're going to be doing some repairs on the bridges, etc., you can just pour UHPC, and in a couple of days, you're good to open up traffic. That's how good it is. You don't have to wait those, n number of days for curing and then, open up the traffic after 21 days. No, no, no. With UHPC, you can do it in 2 days, and, you're good to go. UHPC is also self-consolidating. There is ease of placement. You get nice long workability hours that you can make work with UHPC. One more thing that I want to really clarify, people who have come across UHPC, initially they know that, or probably they are told that a very, very high energy mixer is needed to mix UHPC. That is true, but at the same point of time, I'll tell you that UHPC can be mixed in any other kind of mixer. You can even mix small quantities in a plastic bucket using your mortar or paint mixer, right? You can mix it in a drum mixer. It's just going to take a little bit more time because it's a low energy system. Pan mixers, planetary mixers, twin shaft mixers are really great. Not even that. Let's say if I give you a dry mix of UHPC, you can directly put it into a transit mixer and mix it in a transit mixer, right? A transit mixer is just your regular transit truck, concrete Readymix transit truck. And you can pour your UHPC as you want it. Believe it or not, UHPC can be nicely sprayed and even pumped. I have to tell you that very recently, just about a couple of days back, we pumped, for the first time in the country, we pumped UHPC almost 13 stories high, and we're pretty happy about it. So I've been talking about UHPC for the past 5 minutes, but here is a picture that you want to see. UHPC is mainly just about powder, right? You're not going to have any 10 mm aggregates or 6 mm, 8 mm aggregates or anything of thereabout, right? You are going to mostly have sand in it, and that too extremely fine sand. All other, highly reactive pozzolans and, nice cement and a good super plasticizer, etc. But of course, one of the main other ingredients is your microfine steel fibers. So top right, you can see the picture of the microfine steel fibers, but bottom left, you see the size of the steel fibers. Now these 0.2 mm by 13 mm lengths of steel fibers are, these are very smooth, very high tensile steel fibers, about 2800 MPa tensile strength steel fibers. If you add somewhere about a 2% by volume, which is about 156 kilograms per meter cube, you get extraordinary behavior in not only tension, but you get extraordinary behavior in shear as well, right? And we're going to see that. But remember, the size is very important. Let's not come in and say that I can add 0.4 mm steel fibers or 0.35 mm steel fibers, because you are going to, even if you add those 2% out there, you're going to reduce the number of steel fibers, and that's a problem. because if you reduce the number of steel fibers, the nice composite behavior of the UHPC changes, right? So you want as high as you can the number of steel fibers in the mix. Even if you can find 0.18 mm diameter steel fibers, go ahead and use them, because it's going to even make the behavior a lot more better. And in the pic down below, you can see that UHPC flows very nicely. And I think there's a video over here that you should be able to see. It's a flow test for UHPC, so you're not going to be using anything big. It's a small flow cone that can be used. And once you do that, you would want your flows anywhere, you know, to be between 180 mm to about 250 mm based on the kind of application that you have, right? But you see, this one really did not require any tamping either. So uh, just a very nice flow, and you let it flow for a few more seconds, leave it out there, and then you take a tape measure and go ahead and measure it. So this one shows about close to 24 centimeters, about, so 240 mm. So pretty good mix thereabout. Yeah. So let's move to the next slide. A quick roundabout, explanation, or show of projects, different kind of projects. UHPC is used in bridges. UHPC is used to join all kind of joints in precast. It is used for repair and rehabilitation. It is used for overlaying, over the top of your concrete slabs, not only in bridges, but a lot more in industrial as well, shown below. Used in jacketing, used in different bridge girders, long span beams. This was in buildings. This was the first Indian project. Okay, so what you see over here hung with the crane is the first project in India long span with UHPC. Um, we have also used UHPC, or are using right now, with a composite RCC UHPC column, reducing the sizes. Uh, Bottom left, you see some beautiful facade being done in, this is in Paris, I believe. And, right next to it is a railway station in France, and more industrial slab. It's used in mechanical devices as supports. So UHPC can be used in a variety of ways. So one of the questions that really comes around is, what kind of code are we going to follow? So before, I want to tell you that the good news is that the Ministry of Transport, the MORT, the central ministry, has issued a circular in February saying that the French code can be used for design of UHPC, right? So it's a great thing. So we have some leverage, it's not like we don't have anything right now. So the French code NFP 18-710 is a great code that can be used for design of ultra high performance concrete members. Similarly, I would also say that the Swiss code SIA 2052, shown on the right side, is an excellent document that can be used for design of UHPC. Very soon, I hope that India will also have its codal provisions. Meanwhile, the American code for design is going to come up. It's in a draft stage. Probably might take another year before it comes. So very quickly want to show you, shear strength of UHPC. Don't go to the equations, but without any rebar, you can get a very, very high shear strength. And believe me, bridge girders all around the world made with UHPC, most of them, almost all of them, do not have any shear rebar. Isn't it amazing? So these girders, let's say they are long span, long span really works because, I spoke about the creep is low, so long span works. The strength is high, so you can put a lot more pre-stressing into it, correct? So really advantageous, and even the elastic modulus is high at 50,000 MPa. At the same point of time, the shear strength is also very, very high. So, amazing things that you can do with UHPC. The only rebar I would say that you will need, of course, you're going to put some here and there, you might want to, but the only rebar that you technically may need for some of these bridge girders or even building, beams and girders is at the interface of your reinforced concrete slab and your UHPC girder if you're going to have a composite UHPC RCC system, right? So you need something for the composite action and you can put rebar for that. Also, the bond properties are really good with UHPC. So UHPC, if the surface treatment is, or surface preparation, let me just put it that way. If the surface preparation is really good, UHPC bonds excellently with concrete. Not only that, UHPC bonds excellently with rebar as well. So, almost all structural engineers, will know that the development length typically, for normal concrete, we use about anywhere from 35 times the diameter to 50 times the diameter for development length of rebar. But with UHPC, the development length comes down as low as 15 times the diameter. Isn't it amazing? Now you can reduce congestion by putting UHPC in the joints, right? Similarly, UHPC is very good in bond with pre-stressing steel as well. I'll come in and start showing you some applications because it's a great way to look at projects. Very first project in India, project which had two spans, of 7 meters each. 2 stories were done. This was a school. Owner said, "Oh, at the top story, I want to remove the internal columns. What do? I don't want to increase the load on the external columns because as soon as we move from 7 meters to 14 meter span, the weight of the girders etc. typically increase. So we give a UHPC option wherein actually the self weight actually reduced by 30% compared even with the original version that was there, under construction. So it was adopted. This project got completed last year, somewhere a year back, a little bit of year back, 21 Feb to, February to March, early April, and it's performing nicely. Happy to say that. So this is what it looked like on the site. Very first project, you can see this was post tension, 14-meter long beams. You can see the UHPC pour very nicely going in. So here is a video I want to quickly show how you can move from a dry mix to a wet mix. Now this video is not very clear, but in between it will go dark. But you see right now it is in a dry condition. Let's see, how the video streaming is. You know how well everybody is able to see it. We don't know, but in a few seconds over here, it's going to turn from dry UHPC to wet UHPC. Let's see. On my screen, it's pretty fast, but I'm not sure, how it's coming on your screen. Let's hope you're able to see that. Of course, if you have any questions later on, I'll be happy to answer it. And here it is, nice wet UHPC, flowable UHPC. You can see that inside. Moving to the next slide. Aha! Now you can, this is something very difficult to do with regular concrete, but you can do this with UHPC. You can see these girders, about 84 of them were cast with openings for HVAC and sprinkler systems, etc. Of course, we did some nonlinear analysis on it to make sure that it's, not failing anywhere. But this is something that you can very easily do with UHPC. Aha, another video for you. Let's hope that this goes. Just want to show that this UHPC was mixed in a transit mixer, in a TM. Okay, it did not come from a plant. And it's flowing out now. So, just flowing out very nicely into the formwork. And I hope, should I just repeat that? I'll just repeat this so that, if you missed it, you're able to see it again. Aha. So now you can see that, UHPC can be made in a transit mixer. Oh, nice little bungalow project that we, completed in Tirupati. And you can see the bungalow over there. We did all kind of things with UHPC in there. There were these precast steps that we did. We did the cast in place, joisted slabs. There were composite columns with concrete on the inside and UHPC on the outside. The terrace slab, the water tank, all kind of things were done with UHPC. Another thing that's on the table here are, long span arches in UHPC, and I hope that's going to come fast on the field. Industrial slab that we're working on. Again, a heavy duty industrial slab. Okay, so UHPC girders and compositely connected to RCC slab. Okay, so although UHPC is anywhere from 25 to 40 years old. Okay, so now we are learning about it, but yes, it is anywhere 25 to 40 years old. A lot of work was done in France, Denmark, Switzerland, Germany early on, and kudos to them. Believe it or not, I first heard about UHPC in a very different form, not that word, but I heard it in India in 2002. Yes, 2002, or yes, in 2002. So that's almost 20 years back that somebody was talking about making 120 MPa concrete mortar in India. Of course, people thought that he was crazy. Nobody wanted to believe him, but here we are. Around the same time, the world over work was going on, and this is a project in the United States, and this is the first work of UHPC in the United States. Bridge was made. They were, of course, conservative while designing it because this was the very first bridge. Um, it's been almost 18, 19 years, I believe, and a full-scale testing was done on this bridge. Okay, so yeah, they wanted to make sure that it's all good, right? So they did a full-scale testing of the bridge girder. Another nice project over here wherein the girders were in normal concrete, but the deck was in UHPC. So these were precast decks. They were waffle decks, right? And pieces of waffle decks were put together over the girders, and they were jointed also using UHPC. So the joint was done in UHPC, right? Uh, Very nice, very thin, very lightweight deck, I would say. Another project over here, and you will see that this is pie-shaped, girder. Both the deck and the web is in UHPC, cast at the, same point of time, and put together. And these were also jointed using, right, overlays. UHPC, I said, it's very durable, and that is one of the reasons that it is being used worldwide as a layer over concrete bridge decks. Mhm. Also on the industrial flooring. It's very good in abrasion, right? So it's used on industrial flooring as well. So if on the bridge decks, I use anywhere from about 30 mm thick to about a 50 mm thick layer, you're good. You're good, against my moisture penetration, against deterioration of the rebar, which is in the slab or the beams below, and you're going to have a long life. Quick picture in the middle, I want to show you the middle first. A very, very good surface treatment which was done, or surface preparation. Hydrodemolition was used. On the left hand side, you see simple screed vibrator that was used to screed up the UHPC. And of course, immediately afterwards, a curing compound was put over it. On the right hand side, what you see are pan mixers, and UHPC was brought in jumbo bags or bulk bags and just dumped into the pan mixers. Then they put ice, they mixed it. Once the mix was done, they put the fibers, mixed it again, and then they poured the UHPC. Another bridge in Switzerland where strengthening was done using UHPC. Just want to show you that it's being done around the world. Aha, this is one of the biggest places, where UHPC is being used now around the world, and that is joining any kind of precast elements. So top left, you see at the center of the slab is the UHPC patch you can see in dark gray, right? So it's very, very easy. Bottom right, you can see that a UHPC detail, it's such slim and narrow, and immediately to the left of it, you're going to see a conventional detail, when normal concrete or high performance concrete is being used. Now, if anybody remembers, I just said a few minutes back that UHPC, with UHPC, the development length of the rebar is just about 15 times the diameter, and that's why you have this slim UHPC joint. And anyways, UHPC is so much better in its properties that your joint is never going to go bad. Typically, every project joint is the typical problem, but once UHPC is in, it's not going to be a problem anymore for you. Very nice pedestrian bridges around the world. Right at the top in Korea, middle row left side is Canada. But I come to my personal favorite is the bottom right. This is in the Czech Republic, and you can see how thin this just looks like a bent steel plate, right? That's how thin UHPC can be. It's a very, very simple design, but elegant in itself and very thin, beautiful, just like steel. Quickly show you that UHPC is a major repair and rehabilitation material as well, and we have done some work, and I'm going to show you that. A new building, when the shops took over, they wanted to have some kind of a covering over that, and so we were able to add these UHPC extensions, so as to speak, in front of the building. They were lightweight, and they really worked out well. This is in Mumbai though, right? Repair projects. I'm going to show Florida over here. Project in which a U-girder, normal concrete, compaction was not well. They wanted to place it on the site. So what's the quickest, what's the fastest, what's the best? It's UHPC. They put UHPC in that area where there was no compaction. Honeycombing was there. They cleaned it up, put UHPC. In a day or two, they were ready. Like in a day, you get about 65 MPa. So I believe they were ready to just, take it and place it. Aha. You see, these are precast hollow core decks. And on a project, again, this project in Florida, USA, the hollow core decks, at their joints, in the middle of the slide, you will see that, through the wearing coat or the wearing surface, you're going to see this longitudinal crack. And that's room there where moisture, water, everything is going to penetrate, right? So what they did is, what you see in the bottom right, they dug a longitudinal hole, I would say longitudinal joints were dug in, and they put UHPC, and they jointed all the decks. Okay, so a country that you don't hear about in India so much, Venezuela, and even they have been using UHPC, and this is a marine application. And you see that damaged pre-stressed concrete piles were there. They added a 30 thick UHPC jacket to the piles and called it good. Basically, It's a great repair material. So you can now extend the life of this piles by another 50, 70, 100 years, right? Very simple. Otherwise, these piles could not have been used that easily, right? So now you have a, increase the longevity of the structure. Seismic jacketing. This is in Canada, British Columbia. And this bridge, seismic jacketing was done. You can see at the bottom uh, where UHPC jacket was poured in place. Another example in Canada. And you see this is a railway, bridge, and the entire pier was, spalling was happening. There was a lot of corrosion inside. So they opened it up, chipped it, and they put UHPC. I think on this one about 100 UHPC was put in place, and everybody was, all good to go. Very simple example here. This was in Switzerland, repair. You see the girders, uh, patches, the gray, deep gray patches. That's all UHPC. No new rebar was added because UHPC has a lot of fibers. Just the existing corroded rebar was cleaned up and UHPC was put in, and good to go. Another example wherein heavy duty jacketing was required, where 10 stories were to be added to an existing 3-story structure. Of course, all the way from foundation retrofitting was being done. But left is what the regular solution was, right is where the UHPC solution is, and you can see the size of column has come, jacket has come down, 90% of reinforcing steel savings are there. The epoxy anchoring comes down, the lapping comes down, couplers comes down, because in the original one, the left side, you can see there are 40 diameter bars used as well. Because of architectural constraints, 10 stories are being added. So amazing what UHPC can do for you, right? Save a whole lot in repair and retrofitting. Aha. So another project where there was a problem, the mm, the lap length was not available. Sufficient lap length was not available, but it was sufficient enough for UHPC, right? So at the bottom, UHPC was poured, and then above it, normal concrete was poured again, right? Simple things where UHPC can be used. Here is a quick video of UHPC being poured, starter being poured on a column. It's a very, very short video. And you can see how nicely flowing this UHPC just fills up this entire, space. Move forward. I'll just quickly show some projects in general and move to bridges so that we can finish up fast and then get into questions. Beautiful things like, precast balconies and stairs. These are in Europe. Amazing work. That's columns, nice architectural columns, structural columns, in fact, and some of them are architectural, but all structural columns in this aquatic center in France. Beautiful. Bridge in France with both girders and pencil thin piers, right? So amazing what you can do with UHPC. Aha, nice railway station in France, again in Montpellier. This is southern France. You can see huge cantilevers and amazing, vaults with skylights. Beautiful station. Aha, facade. Again, something so nice that can be done with UHPC. And if you want, there are people doing your wash basins and sinks out of UHPC. It's in vogue, a bit costly, but well, if you want one, these things are coming. Just want to, before we end up, I'm going to show you some quick comparisons. There are some bridges that we are doing some comparisons on for the infrastructure projects, and you can see on the left side I'm comparing a typical PSCI girder and for 29 meters, and suddenly you see the UHPC size has come down so much. But don't worry, I mean, this is not something I'm saying just for the sake of saying that you can reduce about 62% in weight. The size of the first US girder is almost the same. And that was actually 33 meter spans. So believe it or not, you can really come down on the weight of, girders with UHPC. And how does that help? See, there's this original design of 10-meter spans, just has a solid RCC slab on it. But if I change it to some precast RC deck slabs, 220 thick, and precast UHPC girders, it's going to save me a lot of time in erection. Number two, you see the amount of concrete savings is almost close to about 2000 cubic meters, right? Steel savings are there. Of course, some UHPC and PT addition is there, but a whole lot of concrete being saved. Next, what is really important, if you look at the comparison of the dead loads, the original version, the dead loads at the piers are about 2000 kilonewton, but with UHPC, that number comes down to about 705 kilonewton. So now you can design leaner piers and leaner foundations using UHPC, right? There's no span change over here. That was one of the proposals, just a lot of weight reduction. But in another proposal, I mentioned that you can do really long spans with UHPC. Instead of the 10 meters now, you can go with 20 meter spans, and you can remove those alternate bridge piers, which means a lot more savings in terms of both time and money. And amazing how quickly you can go and come out of the project. And here's the last slide. I'll leave you with a thought. UHPC is a material between concrete and steel. Please, it's not just concrete, and it's very, very close to steel in a lot of ways because of its ductility. So it is a material between concrete and steel. People ask me about cost, so here is how I'm going to put it. Imagine that there was no structural steel. Okay, nobody knew about structural steel, right? And if only concrete was used, we know that concrete is somewhere about 7,000 rupees a cubic meter, good high strength concrete, maybe about 7,000 rupees a cubic meter. And if I came to you and I tried to sell structural steel, the first thing you will ask me, how much per cubic meter will structural steel cost me? You're not going to ask how much rupees per kg of structural steel. You will ask me how many rupees per cubic meter. And you know that structural steel is probably going to cost somewhere about 7.5 lakh rupees per cubic meter. Immediately you are going to discard the material. But you and I know, and everybody knows in the world, that structural steel is also an excellent building material. It is being used for projects worldwide, and you can design economical projects. Just the design methodology and the erection methodologies are different than concrete. Similarly, UHPC is a composite material. Its cost will be somewhere about 80,000 rupees to a lakh rupees, maybe even more based on the kind of application. But you have to look at it with an open mind, because the design and the erection means and methods are totally different. And you can come up with solutions that are amazingly different than your regular concrete or structural steel. Right? So UHPC you can use to not only save money in the long term, but also in the short term also, by coming up with good techniques. And not only independently, UHPC can be used compositely with both of these materials, concrete and structural steel. So thank you very much. We'll open it up for questions at this point of time.
Thank you so much, sir, for the valuable session. So here we have got some questions, and I'll read out one by one.
Okay.
The first question is there any special design for the UHPC than conventional concrete? Is the curing period similar to conventional concrete? And that was asked by Mr. Hemant Kumar.
Yes, yes, please. So, Mr. Hemant Kumar, yes, you will have to come up with your own, design mix. There are several which are available off the internet on Google, but you definitely have to come up with a very good design mix for it. Curing is pretty much the same, so you can use water curing. No special curing measures need to be used. But let's say if it's an overlay project and the surface area exposure is more, I would prefer that you should immediately use a curing compound, over the top of screeded UHPC, and that would really work well for you. Thank you.
Thank you, sir. The next question is there any limitations on the maximum cementitious content? And that was asked by Subramanian Shivaramkrishnan.
Okay, okay. So nothing like maximum, of course, we all know, but UHPC, if you look at it, the cementitious content is going to be very high. Even the cement content can hover anywhere between 700 and 1,000 kgs a cubic meter, and plus, your um, microsilicas or other pozzolans that you might want to use along with that. So cementitious content is going to be high. You just need to be careful with your design mix, what you're coming out with. So you also will have to look with your shrinkage parameters and everything else.
Thank you, sir. The next question is what's the major difference between normal concrete and UHPC?
Oh, okay. So well, the presentation kind of showed that normal concrete does not, the performance characteristics are very high. So normal concrete is not ductile. UHPC is quite ductile in nature. Normal concrete, basically, what you're going to say, with UHPC, you can come with a section that's more than 50% smaller than that of normal concrete. Normal concrete is not as durable as UHPC. UHPC is, greater than 50 times more durable than normal concrete, I would say. It is more abrasion resistance, it is more blast resistant, it is better in freeze and thaw. So it's all about ultra high performance, ultra high performance. That's what UHPC is all about.
Thank you, sir. The next question is what should be the strength of cement to produce UHPC? And that was asked by Mr. Siddesh Kamath.
Oh, okay, Mr. Kamath. Today, people are devising their own UHPC for the application. So let me put it this way. Let's not come up with a UHPC and then find an application. You choose an application and devise a UHPC for it, right? So you can use any strength of cement so that it works for your application, right? So it's not necessary that you are going to get that if you don't need that 1 day strength of 65 MPa, but you're good with that 28 day strength of 150, you can use a cement that gains strength slowly, right? Okay, further.
Thank you, sir. Next, we have a question asked by Mr. Ankit Bansal. And the question is, how will be the heat of hydration in comparison to conventional concrete? And is its production eco-friendly?
Yes. So I'll answer both of these questions. Yes, you have to be careful about the heat of hydration because UHPC has a lot of cementitious content in it, and therefore when you design your mix, you want to make sure that your mix is retarded, your mix is not immediately setting. You take your time. There's that early 10-12 hours is very critical in terms of the heat of hydration, so you have to keep it low, right? So that's how we do it. And if we are talking about green again, I would say although the cement contents looks high over there, the material is extremely green. Very simple reason, if I can reduce my, material use, my section sizes reduces by 50%, I am saving 50% of raw material of any kind. If I do not have to maintain it over the service life, I am saving even more, right? So it is green in a lot of ways. Yes. Next question.
Thank you, sir. Yeah, the next question is there any code for UHPC mix design? Is this based on IS codes or not? And that was asked by Ms. Sindhu M.
Yeah, so I mean, no, IS code presently doesn't have a mixed design for UHPC, um, but nobody gives a very clear criteria on UHPC mixed design. But as a material scientist, you will have to start somewhere. The best way to look at it is number one, look at your particle packing, right? So your cement, your sand, whatever you're putting it, the pozzolans, etc. You want to have a very tight particle packing. So if you are able to come up with a very tight particle packing, I think you are going to come up with a very good UHPC. That's the first fundamental part of designing a good UHPC. Thank you.
Thank you, sir. Next, we have a question asked by Mr. Vijay Kumar, and the question is, have you ever faced the issue of cracks in the structures using UHPC?
Not really. We have done a lot of girders, but you still have to be very careful, I would say. Typically UHPC is not supposed to have cracks, right? Because it has so much steel fibers in it, right? About 156 kgs a cubic meter is a high percentage of steel fibers. So the cracks as such will be very microfine, may not be identifiable by the eye. But let me put it this way. If you have something like a floor system, if you're going to put UHPC on it or an overlay, and you got to be careful about your shrinkage characteristics, where the joints you're going to put, etc. Because what happens again, if you're not going to cure it in time, you might have uneven shrinkage from the top to the bottom, which can result in some cracks that you don't want to see. But if you are being very careful, you will not have any cracks in UHPC.
Thank you so
Please.
much, sir. Next question is, what kind of admixtures are used for UHPC?
What kind of admixtures? Of course, you need a very good super plasticizer, right? So you need to disperse all your cement, you need to disperse all your pozzolans, etc. So you need a very good super plasticizer. That's the key, I would say. Apart from that, it really depends on what your application is, right? So based on the application is and where the application is. So the question mark is always there, whether you're going to use an accelerant or not, depending upon the location, whether you're going to use a retarder or not, again depending upon the weather and the climatic condition where you're going to pour UHPC. So let's make it very clear here, there is no one kind of UHPC. You can come up with your own UHPC. Only thing, some good performance characteristics have to be maintained, right? So we need to maintain some good performance characteristics, and you need to make sure that at the end of the day on the site, your UHPC has to work for that particular application.
Thank you
Next.
so much, sir. What are the major tests for designing UHPC?
Oh, okay. Let's start with the simplest one. Everybody looks at compression tests, so that's one. The other you want to look at is shrinkage, right? So you can do your shrinkage tests because that's one parameter to look at. Long term, if you want to do your creep test is one. The other one is a direct tension test. So if you can do a direct tension test, that's one of the best. If you cannot do a direct tension test, then at least you will do a flexural test on the prisms, right? So you can use for these, I believe ASTM 1856 outlines very nicely, the tests. Also, the Swiss code gives a very nice direction on the sizes of the UHPC elements for the test. But if you ask me, if your application is in the colder regions on the overlay, then I would prescribe a freeze and thaw test, and UHPC is extremely good with freeze and thaw. If it's for abrasion resistance, you can do an abrasion resistance test, right? If you're particularly worried about ASR, so there's a test for that. So pretty much all the tests that you would do with a normal concrete, you can do with UHPC, simply put. Thanks.
Thank you, sir. The next question is, are there any suggestions to model the particle packing for UHPC?
There are good models available. I would say, I wouldn't particularly pick one at this point of time, but there are extremely good models which are available in good texts and good research papers. I would suggest that, kindly look at it and, follow anyone. Even if you follow one of the simplest ones around, it would start giving you good results, right? And then you can move to a more sophisticated particle packing model.
Thank you,
Thanks.
sir. Next, we have a question asked by Mr. Adit Gangadharan, and the question is, will the structure interaction be different if we provide UHPC in structural joints only and remaining structure in normal concrete?
No, it's not going to be any different. No, absolutely not. It'll work. It's still cementitious and cementitious going together. So, right now, most of the precast projects, they're using grouts, right? So it's a very similar question, right? So if you're going to be using grouts in your precast member to connect them or put other kind of sealants in there, UHPC is, several times better than a grout, because it's a concrete in itself, right? It's a composite concrete in itself. So UHPC works great with any kind of joints. In fact, the performance becomes better.
Okay, thank you so much, sir. Now
Thanks.
we have one more question, and that is, what are the fire resisting properties in comparison with normal concrete? And that was asked by Mr. Rishikesh Prayag.
Mr. Prayag, very good question. So in bridges, typically, you do not provide anything else as far as fire resistance is concerned. But let's come back to the thought on the particle packing. Because the particle packing of UHPC is very tight, there is no room for the steam to escape, right? And this can cause deterioration in the fire resistance. So the solution is very simple. What you do is, in addition to the steel fibers, you go ahead and add 0.2% volume of polypropylene fibers. Okay, once you add the polypropylene fibers, let's say if there is a fire, even at a low temperature, the polypropylene fibers will melt and they will create these pathways for the steam or the vapor to escape, thereby increasing the fire behavior. So if you're going to use UHPC in building structures, I would advise go ahead and add those polypropylene fibers. Thank you.
Thank you so much, sir. And we are done with the question answers.
Very nice. Thanks.
Yes, sir. Good evening, sir. Good evening, sir. I'm Shelly Fernandez from QCrete.
Good evening, Mr. Fernandez.
Yeah,
Yes.
nice listening to you. Your very interesting topic. All these days we were listening. We were only listening the word of ultra fine, high performance concrete. But today you had shown us that how it is being used in India. Already it has started using in India. Thanks a lot for sharing your views on that one, and I hope all our audience would have very interestingly glued to this particular subject actually. Basically, it is new one, and the application in India already it has started, that we had already shown actually. So thank you very much for your very interesting talk. And you can also feel that a lot of questions were put to you. More than I think the topic, the questions were more shot at you.
I'm happy to answer those. I'm
Yes,
really happy to answer.
yes. And you had done it a very good job of answering each and everything. The participants will be very happy to hear from you, who is actually involved in doing these projects in India actually. Thanks a lot, sir, for an interesting talk. And I also thank the chairman and Anil Baliga of Indian Concrete Institute Mangaluru Center and their EC members for supporting QCrete for conducting this series of webinars. And mostly it is the 50th one, actually, the milestone, which we thought that it should be a thought-provoking as well as purely technical, which the participants should understand that it's nothing to do with any propaganda or anything. Purely it's technical session, and purely the question and answer also will be clearing the technical part actually. So thanks a lot for supporting us, and also to Dr. Satish Jain for coming on to our 50th platform actually, a milestone for us actually. And you are the guest of honor on this occasion. Thanks, special thanks for this particular session actually. Thanks. I thank all the participants who has been participating in our webinar continuously, and they are looking forward to our next webinars actually. I hope in this way we'll even touch 100th webinars also, with a lot of informations coming in from different directions, a lot of achievements, a lot of developments happening in and around the country as well as international actually. I hope we'll be able to bring all those things in this platform. Thanks a lot. Thank you, sir. Thank you, sir, once again for this interesting webinar you have given to us. Thanks a lot to all. Thank you.
Sign off over here.
We'll sign out. Oh, yeah.